Okay, welcome everybody. It is my pleasure to introduce today's speaker, Iván Alejandro González Andazola, PhD student from our department. Many of you, maybe all of you, know him really well. Iván started out as a master's student in the environmental science program, brought here by the famous Stipendium Numericum Fellowship, and started to work with blackbirds with us. And then fortunately decided to stay and take this work to another level, hopefully higher level, as all PhD students should. And so he's going to share his work, some of his preliminary results with us today. And thank you for doing it.
Alrighty, yes, thank you. Thank you, Solis. Thank you for that kind introduction. So yes, for those who don't know me, if anyone in this room don't know me yet, my name is González. I'm a PhD student here, and today I'm pleased to welcome you to my research seminar, which as Soli mentioned it's preliminary results of what my PhD is. It's still not over, so still not the final results. But yeah, it's titled Spatial Demographic Processes in a very widespread, beautiful passerine, right? Partial migrant, also the European blackbird. All right, and let me start my presentation just by giving out some facts, tell you what's going on and why do we study these processes, right? You hear in the title of the presentation, Spatial Demographic Processes. Okay, but why do we study them? Okay, so we know, right, that population dynamics are influenced by the interaction of many factors, many processes, and those are precisely those demographic and spatial processes. And they have the capacity to change and to influence many stuff. For example, movement. They also have influence on distribution of species, or they also have influence on the persistence of these processes over time. And yet, despite being spatial and demographic processes, they never come by themselves, right? They never come alone. They usually come together, they come interconnected. And this interconnection of processes influence precisely the population changes and population structures. Okay, but we also have another layer or another phenomenon, right, which is occurring rapidly around the world, which is urbanization. And we know urbanization is rapidly also altering entire ecosystems, entire habitats, reshaping those processes. If we go a little down, a little lower, these processes that I'm telling you about not only change thanks to urbanization, but they also change across species, right? While some species might thrive in those new conditions, some other species don't, and they just struggle a little bit to persist and to adapt to those changes. And if we keep going down, right, so those changes are not only specific or not only change across species and not only change across urbanization or thanks to urbanization, but they also might change, or they might be differences in those species where within the same population, individuals are still displaying a migratory phenotype, and also those individuals that are becoming full-year residents, right? And this, what I'm telling you about right now, that's what we call partial migration. So partial migration, we understand as within the same population, we have individuals that still decide to migrate, and we have also individuals who don't, right? They just stay and they become year-round residents. And that's precisely what my research is focusing about, right? We wanted to understand all of those, well, not all of those, but many of those spatial demographic processes on a partial migrant, which is also urbanized. I'm going to talk to you about a little bit more about the study system later on. Okay, and since the core of the base of my research, it focuses a lot on partial migration, I just want to make sure we all understand it well, right, with this single figure. So in a very traditional full migration cycle, this is how it looks like, right? In those species which are still very or fully migrant, they have a breeding period, usually spring, the summer. At the end of the breeding period, they migrate to the south, right? They want to look for better areas to spend the winter, to overwinter, usually places with better resource availability, better temperatures. And after a few months, they come back, they migrate to the north. Yeah, they migrate to the north, again, to repeat the whole cycle, right? That's the traditional migratory cycle. But in partially migratory cycles, we still have, like I mentioned already, some individuals who are still displaying a migratory phenotype, still doing the exact same cycle, but we also have other individuals who are residents, right? And by having migrants plus residents, this is what we call partial migration. And having residents and migrants within the same population just opens up other layers, demographically speaking, that are worth to explore, such as changes or patterns in dispersal in different life stages. Also, there's seasonality, right, in survival rates across the different phenotypes. And there might be also changes across different, in reproductive performance across different phenotypes. Okay. And precisely because all of these reasons that I just told you about partial migration, that's what it allows us to do, right? It allows us to have comparisons between those migratory individuals and those resident ones. And just to illustrate a little bit more about this with a couple of examples. So there was a study published in 2007 by Bartek and Weiner, which actually they used the blackbird as a study system. And they wanted to assess whether differences in migratory phenotypes were affected or were selected more thanks to the increased urbanization, right? And what they found out, in just a few words, is that those birds who were more urbanized, right? So those birds in urban environments were displaying higher levels of residency compared to those ones living in more forested areas, which still display mostly migratory decisions, let's say, or strategies. And in a more recent study in 2019, this is also like a wider scale study. They analyzed migratory species. It was not exclusive of birds. They also included partially migratory fishes and partially migratory reptiles. And what they wanted to assess is whether either one of those strategies pose differences in fitness, and fitness measure as survival probabilities. And what, again, in very few words, what they found out was precisely that residency again gave more advantages when it comes of survival probability compared to those migratory individuals. Again, this was assessed across different taxa, different species, so it's on a wider scale. And since, because all of this that I told you about already, we were looking to address my questions, right, and my aims that I will tell you about later. We were looking for someone or somebody that not only displayed this partially migratory behavior, but also that thrive in both urban and forested habitats. And that's why we came up with this beautiful species. Nobody will change my mind. It's the most beautiful bird. And a little bit about these ones, to convince some people here in the audience that they are great. Just a little bit about them. They display this very notable sexual dimorphism, which basically means you can easily identify, right, physical characteristics between the male and the female. And they are found in a very wide, diverse range or type of habitats, right? All kinds of wooded areas, more foresty patches, all kinds of gardens, backyards, farmlands, even crop fields. But across the decades, they have also colonized urban environments, urban settings, urban parks, in just entire cities across Eurasia, and also they have successfully colonized southern eastern part of Australia and both islands in New Zealand. And again, they are displaying this partially migratory behavior still, so that's why they make them a suitable study system for our project. And this map shows you the range or the distribution map of blackbirds across Eurasia. I don't know if you can see well in here in the picture, but this is like a purplish coloration. This is more red, and this is like bluish. So purple, reddish, and blue. The reddish means they are where populations are breeding, so breeding grounds. This bluish, also northern part of Africa, is those overwintering areas for migratory blackbirds. And this purple coloration is where you can find them year-round. Now, I want to put emphasis on this, that despite this is a map of the distribution range, right, for BirdLife International, even though you can find them year-round in all of these countries, right, in Europe, that doesn't necessarily mean that you cannot find or, that it's not present, this partially migratory behavior, right? You can still have populations of blackbirds being residents all year round and migrating in the to the south during the winter, so it's not exclusive. Okay, and with all of this and this little bit of introduction about my study system, my research had two main aims. First of all, we wanted to investigate whether there was a role or the role of demographic processes, specifically talking about reproduction and survival across different life stages. And we also wanted to assess whether those demographic and also spatial factors influence somehow in their movement and dispersal throughout the annual cycle. And in order to cover the first aim, we came up with our first project where we wanted to assess variation in reproductive performance and survival across different migratory phenotypes or migratory strategies, how we call it. Okay, and a little bit of background of this. Individual strategies impact key fitness components, right? We know that, for example, in partially migratory populations, if you're a resident or if you're a migrant, that individual migratory phenotype might have differences comparing to the other individuals, like in survival or reproductive success. But when we talk particularly about reproduction, this particular trait can be influenced not only by your own individual migratory strategy, but also by the collective migratory strategy of who you pair with, right? So it might change if you're a resident and you pair with a migrant partner or with another resident partner. There might be differences here. And that's exactly what we wanted to assess. And these were our three main objectives. So we wanted to determine the migratory strategies of blackbirds first. That's the base of the whole project. We wanted to investigate after whether there was differences in reproductive performance across different migratory phenotypes. And lastly, we also wanted to assess apparent annual survival rates among those different migratory strategies. And the way we did this, so this project has been going on, it hasn't stopped. But for the purposes of this project, we use data collected from 2018 till last year, 2024, so it's a 6-year-long project so far. And the way we did this, since we wanted to assess migratory strategies first of blackbirds, we needed to identify them, right, individually. And to do so, we needed to capture them using targeted mist netting efforts in the winter season or the non-breeding season. So each of the birds that we captured, they were individually banded. We also measured them, and they got an aluminum ring and uniquely coloring combination. After release, we needed to keep track of them, right? And as you can see, here's a picture with with a bird with rings. We did intensive reciting efforts throughout the whole year to precisely locate them, right, and see if they were staying here or if they were not. And since we also wanted to assess not only the migratory strategies, but we wanted to know reproduction, right? We had nest searching and reproductive monitoring also across all the breeding seasons in these 6 years. Okay, how did we determine migratory strategy first? That's the base. So again, like I mentioned, we had an intensive reciting effort from the preceding non-breeding season. So we had a reciting effort throughout the whole year, but in order to assign movement strategies, we only used the recitings of birds that were seen only during the non-breeding season. Non-breeding season for blackbirds goes from September 1 year to February the next year. And the resident individuals were categorized as those birds that were seen on multiple different occasions throughout the non-breeding season. The non-breeding season. For example, they were banded. We saw them in September, again in November and January. That means that the blackbird never left, right? It stayed here. And those migrants that they were not recited locally in autumn, for example, early autumn. We could see them in September or October, but maybe we stopped seeing them, we stopped locating them in November, we didn't see them in the wintry months, but we saw them again in the next year's breeding season. So that could indicate that blackbirds either left, and that's how blackbirds were assigned as migrants. Reproductive performance, we measured whether their breeding attempt was either successful or not only, and we used also the number of chicks in successful nests or the brood size in successful nests. So we had two parameters of reproductive performance in our analysis. And annual survival, since we had data of reciting data, right, across the year, the entire year, we could do a full annual survival analysis that I will explain later on as well, using capture-recapture models in R. Okay, and results. First of all, the determination of migratory strategy. So across the 6 years of the project, we were able to classify or categorize with either one or the other strategy to 607 individuals, which out of those, 129 were migrants and the remaining 478, they were residents, right? This is the proportion, as you can see here in this pie plot. Almost half, like 46% were resident males, 32 were resident females, around 9.4 were migrant males, and close to 12% were females, migrant females, right? And this is just a plot showing across the 6 years that the project has been going on, the number of blackbirds that were successfully categorized as either resident or migrants. Okay, but now when we assess the reproductive performance, right, we firstly assess this on an individual level, right? What do I mean with individual level? I mean that when we found a nest, we counted as a breeding attempt, and where in that breeding attempt, we knew the identity of at least one of the parents, right? So meaning one of the parents was ringed and successfully categorized as either resident or migrant. And for this analysis, we had data across the 6 years of 92 distinct individuals. And those 92 gather all together 329 breeding attempts. You can see residents on your left, migrants on your right. This is the number of breeding attempts per migratory phenotype, the successful being green, and this more white is the failed ones. And when we tested this in our models, we wanted to see whether this individual migratory strategy had any effect on reproductive performance. We didn't find a significant effect here, neither across the years, so this stayed very stable. But we also assess this, but now on a pair level. And what I mean with pair level is differently to individual. This is where in the breeding attempt, we knew the identity of both parents, right? So both parents being ringed, both parents being categorized as a resident or migrant. And for that analysis, we had 30 different breeding pairs. And the 30 breeding pairs collected together 83 breeding attempts across the 6 years. And we had 4 different joint or combined migratory strategies, right? Where both parents were migrants, when the female was a migrant, resident male. The opposite, resident female, migrant male. And when both parents were categorized as residents. When we tested this in our models, whether reproductive performance had any effect due to the combined migratory strategy, we could find that those pairs, where at least one of the parents was classified as a migrant, usually enjoy higher reproductive success. The only one, let's say, significant was where the female was the migrant, resident male. But the other pair with at least one of the parents being a migrant had a marginal significance. This is, as you can see, across the years, of course, since much of our, as you could see in the migratory determination, many of our blackbirds were categorized as residents. We had a lot of breeding attempts coming from pairs where both were residents. And unfortunately, we could only find a single breeding attempt, a single pair, where both parents were classified as migrants. Okay, but when we also measure now reproductive performance, but as the number of chicks that hatch per joint migratory strategy, again, we could find that in those pairs where at least one of the parents was migrant, we had a significant effect, particularly in pairs where the resident was the female and the migrant male. And residents didn't, we couldn't find any effect of when both parents were residents, right? And again, since we didn't have enough data about migrant pairs, we couldn't draw conclusions with that for that migratory strategy. And when it comes to the apparent survival, we measured again across different phenotypes, so residents and migrants. The purple is always on the right if you cannot see it properly. But the cumulative 6-year survival probability for residents was higher than for migrants, of 0.86 against 0.83, sorry. And in our models, again, migratory strategy had no effect on survival probabilities. And also, across the years, it didn't show much significance, just in 2019, where you can see we had this weird event where the survival probability for that year for migrants was significantly lower than for the other years. Okay, and to conclude and trying to answer my first aim, we could see with these results that both survival and reproductive performance did show different outcomes or different results across strategies, probably balancing trade-off. In survival, as we could see, the plot residents were the ones enjoying advantages of residency, in survival. But in reproduction, pairs, not on an individual level, but as a pair level, pairs with at least one of the parents being a migrant were the ones more successful. Okay, and moving on to this, trying to answer our second aim, we came up, I forgot something. My project is focusing on a life cycle perspective, right? And with the first project, we already saw what's happening with birds. We assigned migratory strategies, follow the reproduction. And now we wanted to focus in another life stage in the life of blackbirds. And we wanted to assess now the post-fledging period. And that's why we came up with the second project, where we wanted to analyze the movements in the post-fledging period and also survival of fledglings across different habitats. And a little bit of background, post-fledgling period is a very crucial and important, let's say, stage in the life of every young bird, regardless of the species, right? And why is it important? It's important because it encompasses very important decisions, such as when to leave the safety of the natal territory and when to leave the parents, basically. How to move and how to navigate through different landscapes, and ultimately where to settle down and become independent. But despite being one of the most important periods in the life of birds, it remains as one of the least studied in avian ecology. And based on this premise, we came up with 3 different objectives for this project. We wanted to quantify movement patterns of fledglings, and I want to put emphasis on this, just in the post-fledgling period. We also wanted, similarly to the previous project, we wanted to estimate survival rates, but now by adding a layer of urbanization, by having comparisons between urban and forested individuals. And lastly, we wanted to assess if any other factors were impacting these movements, in this period. The way we did this happened last year in the breeding season that for blackbirds goes early mid-March to early August. And following similar protocols on the first project, we also followed the standardized breeding monitoring because we were interested in fledglings. Fledglings come from nests, so we needed to find nests, locate breeding pairs, and we just kept track of the breeding attempt until chicks were able to fledge from the nest. Each of them were banded, they were measured, and they were equipped with a very high frequency radio transmitter, which weighted like 1.9 grams in average, representing 3 to 3.5 of the total body mass. And we were tracking the fledglings once they got the tag and they were released in a couple months last year, in June and July, using standard radio telemetry techniques. And the fledglings were located once a day each morning until something happened with the transmitter or until we knew the fate of the bird. For example, if we detected them being predated, or whether they died for other reasons, or whether also the transmitter fell off from the bird, or whether the battery died as well. And the way we did this, we were tracking them, we collected a bunch of data. The way we analyzed it, we assigned, or we came up with an age class division for the post-fledging period. And by doing so, we we followed this approach in order to measure how much fledglings were moving as they grew older, right? As they developed in this post-fledgling period. And we had 6 different age classes, 1, 4, 5, 8, 9, 12, or you can see them here. All of those mean 1, 4, for example, days after fledging. It's not the age of the chick, because at the time of fledging, of course, they were already like 12 days old. And also, the way we measure this, we measure daily distance locations, which basically means is the distance that each of the chicks move from one day to the other. Okay, and in the results, we use generalized linear models, and we were able to track down 36 fledglings from 14 different broods. And when we tested whether this age class, these are the 6 age classes, had an effect on those movements in the post-fledgling period, we did find a strong effect here, which is, well, you can see it here in the plot, right? We have our age classes, and as you can see, little by little, little by little, blackbirds were moving longer and longer. These are the distances, right? Greater and greater distances. By the time they were like around 3 weeks old, they were already significantly increasing the movements. The distances they moved, and by the time they were more than 21 days or more, they just exponentially increased, right? In average, across the 36 fledglings, they move 23 meters on a daily basis. Okay, but we were also interested not only to see how the movements change or increase across age classes, but also by having a comparison, right, of more urban and more forested areas or forested individuals. And here, contrary to what we found in the previous result, we did not find a strong effect of, let's say, area on their movements, travel in the post-fledgling period. Here, as you can see again, across both habitats, they were, as they grew older, right, again, they were increasing their movements little by little. By the time, again, they were 21 days or more, they just exponentially moved of farther distances. Important to note here, blackbirds' fledglings are completely dependent from the parents for up to 2 weeks, maybe a little bit more, 2-3 weeks. And by that time, they just become fully independent. They don't rely on parents for food, and that's why this is explained, right? By the time they were fully independent, they just move more. And I was interested to see, not taking into account the age class, because we already analyzed that, but we wanted to see on an individual level what was happening, right? Well, what's going on across both areas. Like, these are the forested individuals, these are the forest individuals. Each of the lines represent an individual, right? A unique individual. And what you can see with this plot here is that urban individuals not only displayed a wider range of movements, right? Very uneven, I would say. This is not... and a very uneven range of movements, but also increased distances compared to the forested ones, which, as you can see, their movements remain quite stable, right? Quite even across all the individuals coming from forested areas. So despite not finding this strong effect of area on the distances moved in the post-fledgling period, we can still see that there's substantial variation of how birds move across different habitats. And the other factors that we also analyze, we could find that clutch and brood size also show a significant effect on their movements in this period, which basically means or translates into those fledglings coming from broods and clutches of increased number travel longer distances in the post-fledgling period. And to my surprise, body mass did not show any effect. And I'm saying to my surprise because in our data set across the 36 chicks, there was some variation in body mass. but yeah, we couldn't find a strong effect. And checking again apparent survival in this period, using similar approach of capture models. Over the 36 fledglings that we managed to track down, we documented mortality in 9 of those, which is like 25%, right? And 7 out of those 9 birds ended up being predated. The remaining 2 died for other reasons that we're not aware of. And the best supported survival model was the one taking into account survival and recycling probability as a function of area. This is G means group, which it was our area, and T its time, or age class for in our case. And the cumulative survival probability for urban individuals was 0.68 against 0.82 of the forested ones. As you can see, well, I don't know if you can see it, but this is orange, this is green. This is forest, and this is this is urban, and this is the forest. Regardless of the age class, urban individuals always displayed lower survival probabilities than forested ones. And here in our plot, as you probably noticed, we excluded our 6th age class, which was 21 days or more after fledgling. We couldn't track forest individuals after 21 days, so we didn't have data to compare them, right, with the urban ones. And okay, and just to conclude this second project, we now know, right, that movement distances in this particular period, the post-fledgling period, increases with age, which reflects the natural progression of fledglings from being fully dependent on the parents and to become fully dependent to become fully independent. And also what I could probably conclude with this is a potential trade-off. And what I mean with this is that across the years, we have collected a bunch of data, and we have consistently seen how predation rate is significantly higher in forested areas compared to those urban ones. But here the results show the opposite, right? So while being or nesting in the city might be safer when you're still in the nest, once your chicks fletch out from the nest, their survival probabilities decrease. And it's the opposite in the forest. Forest is usually very bad in terms of predation. But if the chicks manage to fletch from the nest, their survival probabilities in the post-fledgling period increases. So it's probably a trade-off between the two areas. And lastly, we had another project. This is the most recent ones. Again, since we wanted to see demographic spatial processes across the life cycle perspective. We already saw the fledglings, reproduction, and migratory strategy. Now we move to another life stage, which is again the non-breeding season, but now we wanted to assess whether there were any movements, differences, or due to other parameters such as mold, sex, condition. And a little bit of background. Okay, the breeding season is done. They finished. They were breeding successfully or not, but that's over. Now birds are allocating energy into other processes, right? For example, now they're getting probably fat reserves for those birds that are still migrating, or for those staying. They still want to gain weight to spend the winter here. They're probably allocating energy into predator avoidance or into foraging and other physiological processes, right? And we know that these movement patterns can be influenced by all of these individual traits, but also by the energetically demanding, physiologically associated processes such as feather replacement or molting. So, and based on this premise, again, we wanted to assess if there was any variation in movements during the non-breeding season now, and to influence if any of these factors, sex, age, body mass, had any effect on those movements, and also during the molting phase of blackbirds. And the way we did this, very similar, following the same protocol. We capture birds in the non-breeding season from August to December last year. We capture them, we measure them, and we now we also equip them with very high frequency radio transmitters. And what we did differently here is that we also assess molting. So we, at the time of capture, we wanted to see whether the blackbird was actively molting or not. Again, we use the same transmitters, very high frequency radio transmitters on birds, which now that they are heavier, right, it was around 2.3% the total body mass, the weight of this tag. And the tracking of individuals was again using telemetry techniques. What we did differently this time compared to the fledglings is that we also follow them daily, but now we track them 3 times a day, in the morning, in the afternoon, in the evening, again, until we lost the signal of the transmitter or until something happened to the bird. And we measure the distances, locations, not on a daily basis, but now across times of the day. Okay, and in the results, so we managed to track down 27 individuals, 15 females, 12 males, 7, we call them 1 pluses, which are like older birds, or 1 year younger birds, right? So those were 7 older, 20 younger. And as you can see here in the map, maybe it's not so visible. This is our study site. This is the botanical garden of the university. Each of these color lines represent the movements of the individual blackbirds. To my surprise, when doing this, was that most of the tracking points or the movements of blackbirds happened within the boundaries of the botanical garden. Just a couple individuals here exited the garden, but after a few trips, I guess, they came back. So they stayed quiet, loyal to this area. And when we tested these factors on in our models, we could see that we found a strong effect of molting, right? So those birds that were actively molting at the time of capture display shorter distances compared to the non-molting ones, so they were moving less. When we assess age on the movements in the non-breeding season, we couldn't find any differences between older birds and younger birds, despite some younger birds showing some increased distances traveled, right, compared to the older birds, but we couldn't find a strong effect. Same thing with sex and body mass, so regardless they were female or male or heavier, bulkier or lighter, there was no effect of these 2 factors of on the movements travel in the non-breeding season. But when we included some interactions, right, now we had age and sex again, but by checking whether blackbirds move differently across times of the day, morning, afternoon, evening, we could find that those younger birds, when it comes to age, those younger birds, they display greater distances moved in the afternoon session. And similarly, but taking into account sex, males were the ones, again, moving the most, again, in the afternoon session. Since we also collected a little bit of data about habitat type, we also wanted to check whether there was differences between now the sex and age and habitat type on the distances they moved. And what we could find is that males were significantly more likely to use bushy areas or shrubs and tree cover areas compared to open habitats. No significance across sexes, although it was a little bit of marginal significance. Again, younger birds show a higher probability of using these 2 habitats, right? Moving more in tree cover areas or bushes. And females, as you can see in the plot, were the only ones. Again, remember, we tracked these individuals for around 5 months, and we only had a single event, it's not really visible, of a male using open habitats. The ones only using open habitats were the females. Okay, in this result, we could see it now. We took out age and we included molt. Again, actively molting at the time of capture, and sex on habitat type and the distances they moved. And we could find, similarly to the first result, that those molting birds not only move less, right? They had shorter distances traveled, but they prefer more vegetated areas, tree cover areas or bushes compared to habitat types. To open habitats. And just to conclude this project, also it's still going on, we're still running analysis, but we know that molting birds, based on these results, did show shorter distances travel, preferring those more close or dense areas of vegetation. Age and sex also showed a significant effect when tested right across times of the day. And we knew now that times of the day affected movement, especially in young birds and young males particularly. And okay, just to wrap all this up, my 3 projects so far, because still not over the PhD, we now know that, can probably very confidently say that residency still remains as one very strong, prevalent phenotype in our population, right? A high, as you could see in the first project, a high proportion of our individuals were classified as residents, so it still remains as a very strong phenotype. We checked already with the projects that the demographic factors did impact movement and survival, not in a single life stage, but across different life stages. We could see some seasonality and physiological constraints that influence movement behavior, particularly speaking of molting, right? Those birds molting, they show significant differences here in movements. And we also know that urban and more natural environments present different ecological challenges, or we can also call them ecological opportunities maybe for movement and survival. And with that, I just want to thank everybody that helped out at some point. I didn't list them, it's a lot of people that at some point they help us, but just thank you to the teammates, students, volunteers, and just everybody that at some point just helped us. And that's it for me, and I'm just happy if you have any questions. Thank you.
Thank you very much for the timing.
Yeah?
We have plenty of time for questions.
It's okay.
I have some.
Yes.
Can you go back a bit for the...
Which project?
Yeah, this one?
In those plots?
No, or to the end, towards the end, yeah. Yeah, this one.
That's the last one. Mm-hmm.
You have one data point for the open one.
Yes. You mean for males?
Yeah, open for the males, I think, yeah.
Sorry. This one you mean?
Yeah.
Yeah.
But what is the horizontal line?
Yeah, I was wondering the same. I think it was just plotted wrong. Because, I was wondering, if we don't have enough data, why that appeared. But, I don't have other explanation in this.
Yeah, because it should be much over
Yeah.
the place.
Yeah, in zeros probably. Mm-hmm.
Just a moment. Yeah, you said that you determined the migratory strategy
Yes.
for birds who disappear during the winter,
Yes.
but reappearing in the spring.
Yes, in the breeding season.
And for the, do you use the same criteria for the resident birds? So I mean that you have it at the beginning of the winter. Of course, you have them during the winter.
Yes.
But do you have in the next spring too?
Yes.
Okay.
Exact same criteria for both phenotypes. Yes. Yes, for those resident individuals, since we never stopped the reciting effort, literally never any month across the 6 years, we had a lot of data for the residents, right? Multiple occasions, and they were seen again on the spring during the breeding season. Yeah. Same
only,
criteria.
only those birds are included in the analysis to see in the next spring.
Only those, exactly. So birds that, only those birds, exactly. Mm-hmm.
And have you observed any change in migratory behavior? So one bird's resident in 1 year and then
So
migrating to the next year?
Yeah, it's not included in the presentation. I tested this to check like repeatability, right, of migratory strategy across the years, and there was no effect. So, and also if you check individually or database, I mean it's a big one, but we already identify a few birds that we've seen them across the years, and you can see across the years they just, for example, residents remain residents, right? If I remember correctly, a couple of times, just a couple of birds that came to my mind right now did switch strategies according to our classification, but most of them just remain with the same strategy across the years. Yes. So no significant changes there.
Yeah. One more thing is that when you follow the birds, follow the fledglings.
When it was, sorry?
When you follow the fledglings.
Follow, yes,
Did you analyze the distance from their nests over the days, or just the distance between the different sites?
Yes, no, we didn't analyze that from the nest, no. Just distance from the previous location, right? But never from the nests.
That might be interesting because that's more characterize the dispersion from the breeding area.
Okay. Yeah, and that's easily done, right? Because we know where the nest is, so we could easily calculate those distances. Yeah, I haven't thought about that, but I'll check it out and try to include it in the models. Thank you.
And just a couple of comments for the presentations. That in some of your figure is not consistent. So, for instance, when you are talking about the migratory strategy of breeding pairs, in one figure you have NN.
Oh yeah. You mean the order?
Yeah, and then on the other slides,
it's
just switched.
Yeah.
And then another thing is that please put up more information about the analysis.
Okay.
Because you mentioned one time that you use the GRNN,
Yes.
but in other times not. And that would be important
to explain further. Yeah. All right.
You don't need to explain it, just put it on the slide.
Okay. All right. Thank you so much. Yes.
Yeah.
Thank you, sir.
Very close.
Thank you. Anyone else?
Yeah, thank you so much. Nice for the good, nice presentation. What I want to ask is that you use this model that we capture method to estimate the survival probabilities.
Yeah.
Does it mean that disappearance from being recaptured is the conclusion for the death of the bird? Is it a conclusion that the bird has died, that you didn't capture again?
You mean that if they were not seen, that means they died?
Yeah. Is it the conclusion that you didn't survive?
Not necessarily. I mean, that's the name of the analysis, right? Survival. In theory, probably that could indicate that, okay, since you didn't see them ever again, probably they died. But I don't think that can be the case. For example, in our study or in our population, probably I didn't see birds again ever, but that doesn't necessarily mean they died. Or they just probably moved to other areas that we're not checking, right, regularly. This came to my mind when I was running those models because we had a few birds who were abandoned long time ago. For example, Noemi actually just saw one today that was abandoned in 2019, if I remember correctly. 2019, if I remember correctly. But it dispersed to other areas of the city, so we didn't have data about him for years, and we thought it was dead, right? But it came back again, or we just saw it again, and now it's changing, right? So the survival probability for that specific individual, it's gonna change now because it doesn't mean that it died and came back to life, right? It was just outside of the study area, I guess. Yeah. So it's not. I don't think answering your question. I don't think that's the conclusion.
Yeah, I'm not so sure how heavy the transmitter is. If you touch the bed, could it change the migratory behavior of the bed itself? Maybe because this is something that I haven't experienced. You can move outside of the range that you experienced. Okay, this is my study area.
The migratory phenotype, you mean, or just their movements?
You attached the transmitter, right?
Yeah, we attached them.
And then that is something that a bird has never experienced. So it's something like a foreign state. That's definitely not body. So I'm asking if that transmitter will change the migratory behavior of the bird itself, and then it can move maybe far away from the area of detection.
I don't think it changes the phenotype, right? The migratory phenotype. It might have an affectation or an effect on their movement, the way they move or how far they move, I would say, but not necessarily the phenotype. This has been well documented in tracking studies, right? They have been checking this, whether this extra weight at the end of the day is an extra weight, right? That from 1 minute to the other, you're putting on the bird. Despite it's low, right? It's around 3.5% of the body mass. This has been analyzed, and in many studies, they have not found any, let's say, repercussion. Also studies, they always suggest that this extra weight you're putting, whether it's a radio transmitter or a GPS or something, never exceeds more than 5% of the total body mass of the bird, precisely to not affect any kind of behavior. For example, in our studies, in our projects, I don't think it has affected their migratory phenotype, neither their movement strategies, I think. We have seen a couple of birds still, since we keep going with this reciting effort, right? We can locate birds, not by the tag, but by the rings, around in the botanical garden, still carrying the radio transmitter, and they seem perfectly fine, right? Even we have recaptured them, and that's when we take out the transmitter. And at the time of recapture, again, we measure them, body mass and everything, and most of the individuals, they gain weight also. So it's not like they're getting constrained by it. So, yeah. Thanks, man.
Anybody else?
Thank you. Very nice presentation, and really like it. I also like visually appealing presentations, and this is very nice. I had a couple of questions. Some of you partly you already answered. I'm especially interested in the phenotypic plasticity of this migratory nest or residency, and partly you mentioned this, but you use very often the expressions like individuals decided to migrate and that, so that really suggests that you think that this is a phenotypically plastic trait, although in response to Zoe's question you said that there's not much evidence for this kind of switching. And what I would be interested whether you guys have ever analyzed the heritability of this trait, because you have long-term
data
monitoring and
you mean like from a parent to
exactly.
No, we've never done that. Although we could try it to see. Yeah, we could try checking out the database, right? Whether since all the chicks from those breeding attempts get rings, I could check if we have enough data to determine migratory strategy of those chicks. But we've never analyzed that yet. Yeah, I will take a look. That's also interesting, I think. Mm-hmm. Oh, sorry. Yeah, it just came to my mind. I think it will be worth it because, like I mentioned, we have some individuals that we already know them, and they know us, I'm pretty sure, for years. And we always find their breeding attempts, like year after year after year. So, and we know, for example, for those particular birds that came to my mind, that, for example, one that we always see here in the garden is always a migrant, always every year. I could check like his chicks, right, his fledglings across the years, whether they retain his own residency strategy. But we haven't done that. We haven't analyzed that.
It could be interesting.
Yeah, it could be interesting.
I have a couple of few minor questions, but just interested. So, for example, in when you said that in the tracking study that the birds remain in the botanical garden, so how much sampling did you do actually outside of the botanical garden? So how much is the potential observation bias rather than actual movement?
Yeah. Maybe I'm biased because I did it by myself, but I did a lot. I did a lot of this tracking outside, actually using my bike. That was the faster way, you know. Maybe some people saw me driving bike with the antenna, and I actually have like routes with the bike. I checked Medical Campus, Augusta, this, I don't know, the street that crosses the forests, and then Kartac Street, some areas in Chestaker, the campus. So I did a bunch of also tracking outside of it. That's why we could locate, you could not see it in this map, but the few birds that actually exited the garden, or a few times they went to the, for example, in front of the main building, or they cross this Dolci Joseph street to the, we call it Chestaker, right? To those areas, but it was just a few times, and those birds at the end came back to the garden. Yeah.
Okay. Yeah. I was also wondering about the variation in fledgling time, because in the movement you measure this from the fledgling, but I was wondering whether there's any either habitat-based difference or just normal variation in this.
You mean for the fledglings, right?
Fledglings, yeah.
Yeah, no. You mean fledgling time of the day or time of the season?
No, what I mean is that there must be maybe variation in when they fledge from the nest. That could be even driven by, you know, like if you scare them and they just jump out.
Okay, got it.
Something like, or there's just natural variation. Some of them stay longer for the nest than others. And then how can this affect potentially your estimates of the age class, because this is always measured from the fledgling time?
Yes. Don't know, not sure if I understood that. Because when we put out the tags, right, on the chicks, it was on the fledging day. We put them always in the nest, but they fledge on that day. I mean, because we kept track of the nest, right? So it's not like we put the tags and then they stayed a couple extra days and then fledge. No, it was always the case that in the 14 broods that we analyzed, we put out the tags.
The same day.
So it's forced fledging basically.
It's forced fledging based, yeah.
12th day,
Exactly.
and they would naturally fledge according
Yes.
to literature. Obviously, there is variation, so some would maybe fledge on the 14th, some might earlier, but we are forced fledging them. By putting a tag on them and putting them back on the nest.
Yeah.
And then they will leave.
Yes, exactly.
Okay, that makes sense. And I have a final question: is that the two habitats, the forest and the urban, you know, maybe distinct, but still, I guess it still belongs to the same population. And I was wondering whether you guys have any plans to do some sort of population viability analysis, because some of the vital rates that you show are actually quite low. So I was wondering whether this population itself is self-sustainable, and especially if you take the differences into account between the habitats. So what could be the population level dynamics of this? Can this population sustain itself, or maybe there's an influx from one habitat to the other one to keep it, or what's the story?
Yeah. Well, we haven't talked about including this, but that will also be worth. We have talked about it, like with the team members. We've always concerned about probably aligned to what you're saying or the comment you're saying. How do this population actually persist, right? Because across the years we keep seeing high predation rates, not only in the nesting phase, but also, for example, post-fledging period. 25% of the chicks died or were predated, and there's also a loss of nest failure, not just for predation, but other causes. We've been wondering about it. We haven't talked about running analysis like this, but probably we should. Yeah. Mm-hmm. Yeah. Thanks. Thank you.
Perfect. It's 1 o'clock. Okay, you get one more question. Last question for that.
Thanks so much, Iván. Appreciate the presentation. I was curious about the survival of the fledglings between the forest and the urban, and we expect that the predators and so on are reduced in urban, but the survival of the fledgling was low in the urban and the forests.
Mm-hmm.
So what could be the reason?
The reason for that?
Survival of the urban.
Yes, we've also been wondering about this. Like I mentioned, probably nesting in the city is safer, but at the time of fledging, it's survival goes down, right? There's many threats in the urban environments, especially in the areas that we worked on. For example, you fletch, they're exposed, I don't know, cats, dogs, a lot of people coming by. We saw a couple of birds being, not the fletchlings, but adult birds being rolled over by cars even, disturbance by people, yeah, all kinds of threats that probably forest individuals do not face, right, at the time of fletching. We had a study site which is very urbanized in the south of the city. We only managed to track down like 5-6 individuals there with tags. And if I remember correctly, two where I actually saw one cat eating one. The other was being pecked on, or it was like kind of being bothered. It was already dead, but it was being bothered by a crow. People in general were passing a lot, and I don't know if that also has some kind of repercussion. A lot of cars, roads. So I think those reasons can explain this lower survival rate in urban chicks. Yeah.
Could this be same to the adult birds?
I'm sorry?
Could this be same to the adult one, the adult birds?
To adult birds? Well, they definitely also face threats like cats, right? In areas of increased urbanization, or like residential areas. I think there will be a significant difference of survival of adult against the chicks. Also, chicks at the time of fledging, they're not able to fly. That's an important thing, right? So they fledge from the nest, but they stay on the ground for a few days before they can actually kind of start jumping and find a branch or something. So they're totally exposed. So I think for adults will be completely different in other ways. Yeah. Mm-hmm.
All right, let's continue this over lunch, and thank you, Iván, again.
Thank you.